Yeah. Hello, everybody, to this afternoon session on Reactive that meets data access. My name is Christoph Strobl. I work for Pivotal, obviously, and I work there as an engineer in the Spring Data team, and I'm mainly responsible for the data abstractions around MongoDB, Redis, a little bit of Solar, JPA, and all that stuff. And I guess you've been already fluxed in for the past 1.5 days quite a bit. So we've heard about all the reactive programming still. And so what I wanted to do is basically not bore you too much with just the reactive stuff that we are doing. So what I'm going to do is I'm doing not only reactive data access, but I want to use the time that we have together a little bit to also introduce you to the breaking changes and all changes that we did with the current, that we're going to do with the current Spring Data release. With the Spring Data K release, or 2.0 if you want to call it that way. So let's start off with what we're going to do the next 50 minutes. I'm going to tell you a little bit about where we are today actually with the Spring Data project, with the Spring Data K. We released recently milestone 2 of it. I'm going to go into the details in a bit. Then we'll have a look at the reactive data access stuff that we're doing with the Spring Data K release, mainly for the NoSQL stores, obviously. And at the end, I'm going to show you some code that is actually available right now in combination with some Webflux stuff and other things you probably have seen in some other, maybe different way, in another presentation already. Okay, let's start off with Spring Data K. Where are we today, actually, with Spring Data K? We released a first milestone last November, and that one focused mainly on support for Project Reactor. So we wanted to ship reactive data access and the reactive paradigm pretty early in the release process, so we had it in the first milestone already, basically mainly for MongoDB, and we started off by implementing a Redis connection in a reactive way. With milestone 2, we also focused on the reactive side of things a bit. So we added support for RX Java 2 and that stuff, and a bunch of other things, and some code improvements, Java 8 upgrades, and that stuff. So that was milestone 2. We are currently at milestone 3, and that one introduced quite a bunch of breaking changes that I will go into the details a bit further, mainly on the repository layer and the CRUD methods and return types that we offer there. We plan to do a 4th milestone this month, hopefully, and then RC1 in June, and we are eager to go GA in July 2017, so a bit after Spring Framework, but still before boot at the end of the year. The current plan is that we just gather feedback on the 2.0 or K release, actually, and then release a Spring Data 2.1 for the actual boot release at the end of the year. So what has been the Java 8 baseline upgrade? It's basically one for us, since we're following up the Spring Framework 5. So we finally are able to use all the new language level features, and we had a chance to get rid of all the bloody hacks that we had in there to support Java 8 already while sticking to a Java 6 code base. So this was a huge improvement for us, and by now we polished stuff up a little bit so that it doesn't only look like it was a Java 8 code base, but it really feels like a Java 8 code base. And yeah, and we revisited some of the core concepts that we follow with Spring Data. So what does this actually mean? Currently, if you look at the Spring Data repository, at the moment, and what you recognize up there is that we have some ID that has to extend the serializable. This one is actually owed to some Hibernate limitations, as far as I remember, and with Spring Data K, we just removed that limitation, and so you don't no longer have to extend the serializable, because it doesn't make any sense for many other stores that we support. So you don't need the ID to be serializable for MongoDB or for any of the, or Redis or any of the other stores. Okay, let's move on. We decided to remove basically the null return types on repository level. So what you see here is again the Ingalls release, and what we have here, we just return a T that might return null, as the java.comment says. With the K release, we decided that on repository level, we'll remove all the null return types, and instead of that, we'll just give you an optional. So this is a breaking change. You will recognize it if you pull the Spring Data K dependency into your project, maybe an existing one, then your code won't compile anymore. So be aware of that. What we also did, and this is also a breaking change, we changed the naming quite a bit. So what you see here is again the Ingalls release, and you see up there's find one and save, and there is even a save with an iterable. And if the it sometimes happened that people just had, imagine you have a person class and the person has colleagues and the colleagues are persons again, and then you implement iterable on your person class and just return all the colleagues. So then the Java compiler doesn't know which one to choose actually. So this is a problem. And so we came up with a more consistent naming. So basically everything that's currently named find1 is now called find by ID, which is actually the stuff that you're executing behind the scenes because you want to look up something by its ID. Same applies then for save with an iterable. So this has become save all, and that goes on just down the stream. One thing you have to be aware of is, of course, you could have now a custom repository implementation that has exactly the find by ID method signature in it. That could be a problem. But again, since we're returning an optional right now, which is something you probably are not doing in your custom implementation already, you'll get a compile error once you pull in basically the dependency. But be aware of that the method names changed and are, in our opinion, more concise now to what the method actually does. Then what we actually plan to do is we want to have some composable interfaces. This is some feedback we got from the community, basically, because if you think of Spring Data REST and you expose a CRUD repository, then you're basically exposing all the endpoints, so people could go on and then just create entities, delete entities, and not just look them up. So what we want to do is basically we want to split that up a little bit so that you got more fine-grained control of how your repository should behave. So it should be something like you can insert stuff, so this will be insertable, and you're allowed to read, but you cannot update nor delete stuff from the repository. The names up there are current working titles, so this is something we plan to do. Still not in place. We hope to get it done for M4, but the names are subject to change as we move on in the iteration. There is another thing that we plan to change related to custom implementations, because who of you has ever done a custom implementation with about the half of you? And what we think is that it's kind of strange to have a full repository that extends a custom repository. That part is pretty fine, and even having a custom repository. But then it comes to the part where actually you got a full repository impl that implements the custom repository, which feels kind of strange when you think about it, because you would expect it to implement the custom more the full repo instead of the custom repo. So we want to change that actually, and introduce a more concise naming in there as well, so that actually the custom repository implementation is meant for the custom repository. So again, the names should match better. And the same goes for the readable and what have you, findable implementations. So there'll be a bunch more implementations than in place. Again, this is subject of change, and we hope to do it for M4. We're still working on it, but it's not there yet. Hello? Yes. Then, if you look at current template level APIs, this is copied from MongoDB, so this is Mongo operations in there. What you will recognize is that when you basically type a template dot, and then the list basically goes over your whole screen, because there are so many overloads for each and every method. just adding, like, let's say, the collection for the class, or then for a projection, then just another overload, and internally those all just move on. And if you are then basically writing your find method, template.find, you can imagine what the query part is. But as soon as you're on the person, so does the person mean actually? You could imagine that Star Wars would be the collection, but what has Jedi to do with it? I mean, unless you're using IntelliJ with all those parameter name hints, then you can easily get lost in there. So what we try to do is we want to try to have or provide you with a more fluent API that allows you to basically write that stuff like this. So you go there, you query for a person in a collection, returning some projection type, so that you basically, the first class, the query type is used for mapping the query, and then you return another type. You can skip that if you're just interested in personal and Jedis, and then you basically trigger the execution by calling the find by method. So this feels much more naturally in writing the query, and we hope to give you easier access to all the API that we are exposing. And of course, you'll find a lot more builder-style APIs in general in the Spring Data codebase. So there will be pageable nones and sort, unsorted, and whatnot builders all over the place. So there's a bunch of API coming that just makes stuff more readable. Okay, you've seen that probably if you've been to Sebastian's session today. He also contributed Spring Data MongoDB Kotlin extensions, which basically allows you to omit the types and all the syntax goodies that Kotlin brings you. So this is how that looks like. We also plan to do it for the fluent API style. That's not in place already, but we plan to do it for those as well as the reactive stuff. And yeah, having that said, let's move on to some store specifics that we plan for, already did for Spring Data K. Let's start with MongoDB. One of the major steps in there was basically switching from the DB object-based API towards the document API. So we no longer support the MongoDB 2.x whatnot driver, but we switched fully to the 3.x driver generation. So this is a huge change. We also support the Reactive Streams MongoDB Java driver, and on top of that we built a Reactive Mongo template as well as the repository layer. We'll see those later when I show you some code. We invested quite some time in enhanced aggregation support. We also backported it to the latest English release, at least part of it. And recently we added collation support. For those of you who don't know, this basically allows you to influence how strings are treated internally in MongoDB for the query or an index or whatnot or when you actually query that stuff. For Cassandra, there is also a breaking change because we upgraded to Cassandra 3.2 with different APIs. My colleagues basically went through all the Cassandra templates that had been in place already, removed stuff, revised stuff, and revised the whole template. So there's currently an imperative template, there is an async template, and there is a reactive template as well as a reactive Cassandra repository. One word of caution on that. Cassandra doesn't currently offer a native reactive driver. So what this actually is reactive over the async driver, which is kind of mimicking reactive behavior while having a thread pool underneath and then blocking at the end of the day. And what they also did is they merged the Spring Data Cassandra CQL module into the Spring Data for Apache Cassandra module itself. So that artifact just went away because it didn't make any sense because everybody was basically just using it with the Spring Data Cassandra module itself. So pretty obvious. For Redis, bad news for those of you who used SRP or JRedis drivers. The support for those has been discontinued because There has been literally no movement over the past few years for those drivers, so, and they couldn't keep up with the latest Redis versions and whatnot, so we just decided to ditch those, and we upgraded to Lattice 5.0, which is not GA yet, but still we have RCs and milestones for that because it offers a native reactive driver for Redis. And on top of Lattice, we of course built the reactive Redis connection as well as the template. Repository support will follow later on. We don't have it yet. For Gemfire, anybody using Gemfire? Just curious? Okay, no one? It's a distributed data grid if you're into something like that. The thing I want to mention is that we built in Lucene support in there, which is a huge improvement, because with the Lucene support in there, you're basically now able to do something like pagination in Gemfire or Apache Geo, if you like the open source product more. For Solar, we upgraded to Solar 6, because that required Java 8. We weren't able to do that before. And we enhanced the collection API a little bit, because the client allows us to do so now. And one thing I want to mention, this is more a Spring Hatewis topic, but it influences Spring Data REST. Greg is currently working on the support for more media types. Currently, if you're using Spring Data REST, you're basically bound to JSON and the HAL format. We're working on it to support Siren and whatnot, and provide you with extension points so that you can basically hook into the transformation and the rendering so that you can apply your own rules to the transformation and conform to whatever media type you want to have. That's also work in progress, but it looks very promising, and we are eager to get it into the release. Perfect. Let's have a look at synchronous data access that we're doing today with the, I guess you've heard about it, with the Spring Data stuff. And it all starts basically with a Spring Boot application with an input, something triggers an input that goes back to your backend. Sometimes you talk to a rather slow data source, maybe, and this will take some time, and then you wait for stuff, and then you go to other data sources, fetch some more data, return that stuff, and the incoming thread is basically idling around while waiting for the data. I guess you've heard that before at this conference. So what this actually does is, like, if I was about to move that pretty sign for Spring.io hashtag from that place to here, and it was just me, myself, and I would go there and just pick an item, and then I'd walk back and put it here, and then I'll go up for the next. This is not really efficient and takes a lot of time. So what we came up with over the past few years is basically what we did. We went on to batching. So we basically batched stuff up, went to the data source, we got it from there, and then we went on with just a bit more load, but it was more efficient. So it would be me taking, let's say, I could probably carry 2 or 3 of those signs, letters, and just move them over there. What I do by doing this is basically I increase the workload, because I can only handle a few of those. On the Java side, you just basically increase the memory consumption and whatnot. So again, this works pretty fine so far, but it's not very resource efficient, and that's what Reactive is about. It's about reactive It's about efficient resource usage. That's what I wanted to say. Sorry for that. Okay, so what we have another strategy to cope with that, and it will be asynchronous data access. So if I'm not able to carry all that stuff by myself, what I normally do is I invite some friends, help me carry that stuff, and that would be, in our case, worker threads that then just go on asynchronously. Just go there, each and everyone takes a few of those letters, carries them over, puts them in place, and then at the end of the day we are done, but we are not done until the last of us just brings that stuff over here. Again, we're increasing workload on the server because we got some more threads that are doing work, and threading is costly, as we all know. And so it's, again, it works pretty fine for most of the applications, but it's if you're on a high throughput application and you need to care about your resource usage, you might not want to do this. So reactive data access brings that all to another level, so to speak. So we're gonna lean back a little bit and move to another level. And we're talking about publishers and subscribers. And the subscriber basically requests data from the publisher, and that returns the subscriber, so to speak, stream of items. This would be like if my friends and I from the asynchronous world would just build a chain and someone grabs the stuff over here, and then we just pass it over just to one and the other till we are here, more or less. And what we got here is some control. So basically we can say, oh, this is the back pressure knob. You can just give me 2 at a time, or I can't handle any more of that stuff. Great. So what we did with the reactive programming model is basically we went from a poll model, from iterate or future, where we're basically asking stuff constantly from the source, give me the next, or get me some stuff. We're moving towards a push model where, yes, please. A bit slow today. Yes, we're moving to a push model basically, where when the publisher is ready, it basically just gives me the element so that I can do whatever I want with it. And this works pretty good for the NoSQL stores, because they don't have those strong assumptions about consistency and all that stuff. So they're pretty ready for all that stuff. And this is why most of the NoSQL store providers actually give us the opportunity to benefit from the reactive programming model. With Spring Data, we have it for currently Redis, MongoDB, Cassandra with caution, as I said, and Couchbase. Couchbase, those guys had actually been the first in the Spring Data family to really embrace the reactive programming model. So as they built their Java driver on RxJava itself, and then just wrapped a blocking API around it so that it was basically usable with the current Spring Data Ingalls release and those before. So it's pretty easy to go from reactive or non-blocking to the blocking style. Just wrap it into and then call block or whatnot, or subscribe and return that stuff and collect. One question that always comes up is, so what about JDBC and that stuff? And well, you heard probably when you've attended Josh this morning that it's not really a good idea, and that JDBC isn't really ready for that kind of programming. What one could or might want to do is basically have some, let's say, unit of work that might be a single transaction, whatnot, doing some stuff, and that gets then executed by a thread pool, basically. So you could just not block in first place, then defer the execution, and then have a blocking API calls in, and then just return that stuff. And this works to a certain degree, because you could add stuff in there, and the thread pool could take it, and yeah, still it doesn't really feel really great, so you still have the blocking API calls in there, and once you keep adding stuff in there, at some point the thread pool won't be able to handle it anymore, and then you're basically blocking your reactive API chain. And so this isn't a really good idea at any point. Though we are still monitoring that space pretty carefully, and we already experimented with exactly that approach quite a bit. And what we found out so far is that you still could kind of benefit and increase the throughput by using such a model. If you're willing to live with the, willing to maybe step back a bit from the paradigms that JDBC put on top of you. So basically, if you're okay with just, if the thread pool can handle any more, then just drop it and do nothing. If that's okay for you, you can just increase your throughput. Jens is currently working on that. He built a demo application, not publicly available right now, but you can increase your throughput nevertheless using that approach. But let's focus on the NoSQL stores that we currently have support for, mainly the ones I've already talked about. For Spring Data, we, as well as Spring Framework, depend on Project Reactor in the 3.x version, Spring Framework 5, and of course Spring Data K. So I've talked about Redis before a little bit and the Redis driver. So those of you who are familiar with the Spring Data Redis project know that we support more than one driver. So there is, at the very low level, there is a Redis connection that is just a wrapper around what the driver APIs. And if you have a look at the reactive Redis connection, currently only available for Redis, because Redis doesn't offer reactive API by now, then you'll probably find something in there like a get command, which is just get the value for a single key from Redis. And this obviously returns a mono, because the value could be there, or there is no key to fetch, and then it would just return an empty mono. So far, so good. Still, if you would go for a keys command, which would just list all the keys, that would obviously return a flux, because that would be multiple values, or no value at all if there are no keys stored in there. So those are the easy ones. Still there, Redis has in its API a contract. And that might look like this. So there is a multiple get command, which is called mget. And the contract is as follows. You give it a bunch of keys, and it will return you the values for those keys in the exact same order as you requested them, and it will give you a null value for keys that don't exist. Well, if you follow the contract, you can't just return a flux, because you cannot emit a null value with a flux, because that would just wouldn't be existing if you're going through the mapping stuff. So what we have to do in order to keep that contract is basically creating stuff like returning a list of all those values, because within that list we can just stick to the contract that we have to fulfill in order to just follow the Redis API. So this is something that we're trying to do with with Spring Data in general. We don't want to change the store behavior itself. So we couldn't just emit the flux at this point. We do where we can, but at this point it just doesn't work. For MongoDB, it has been a little bit easier. This is an example of reactive Mongo template, actually, because there you'll find methods like find one. Those are pretty much the same method signatures as you'd have on the imperative currently available Mongo template, with the only difference that it's basically triggering using the reactive streams MongoDB Java driver and returning you a mono. The original driver doesn't have it's based on reactive streams, so it would just give you a publisher, which we already learned can be anything, so it has no notion of how many elements these are. So this is something we changed in here, because we got a mono, so there is a meaning behind that. Find one could be one or nothing. And of course, the same applies to the find all methods, just returning a flux. On the reactive repository side, it's been pretty easy for us. Once we decided to go that route, so basically it's a wrapper over the templates that we offer. So you have a save method that gives you a mono in return. You could also call the save method deferred by just pushing into the save method a mono itself and just return a mono once it's done. So you basically only start saving when the value is available and then just return it when it's done. The same applies to the save all methods. You could add a publisher in there, so save all would also work with a mono if you want to, or you could also push in RxJava observable, because that one should also implement the reactive streams publisher. And of course, there's all the other methods that you would expect to be there from the imperative repository, CRUD repository. So there exists by ID that in this case returns a mono of, and so on and so forth. So you should find your way around in the reactive world using Spring Data pretty easily, because you're familiar with the structures that we offer. It looks pretty much the same methods, simply the return times and the execution model behind changed. And if you're now using writing a reactive Spring Data repository, your entry point is, of course, instead of simply CRUD repository, it's the reactive CRUD repository in this case. All the other things stay the same, so you can basically have derived finder methods. You could write find all by last name, returning a flux of all people with the matching last name, and that would be perfectly fine. You could also use, again, put in a mono for the last name, so as soon as the last name gets available, and let's see, you get the point. It also works with the @query annotation. You could even add a mono for the string in there, and again, we'd resolve the query once it's done and return you the results. And there's one special thing. Most of you know the pagination mechanism that we have in Spring Data. And in the imperative world, this method, find all by last name and the page, normally you'd expect it to return a page, giving you the total amount of elements in the collection, and if there is a next page, has a previous page and all that stuff. We decided explicitly not to do it, but rather use this pageable argument to pass on offsets and limits and sorts to the underlying store. I mean, you just could go on and say flux and then just take 10 elements and then just leave it there. But that, then again, you would just read potentially from the database stuff that you don't want to read. And this is a way to just tell the database where to start in returning data and when basically to end, instead of loading stuff and doing it in memory. And of course you can do if you want to, but that's the way we planned it to be. So you could, if you just want to do sorting, there's no need to pass in a pageable argument. Actually, you can just pass in a sort parameter, and that would get applied as well. Good. So far, let's have a look at the demo. I'm going to show you some code. I've prepared that already. I know that Josh loves playing around with start.spring.io. I'm not going to do that. Actually, I just prepared some stuff. It's as if we were going to start Spring.io and download and choose Reactive MongoDB and Reactive Web and all that stuff. What I've done here so far is basically I set up a bunch of test data, some of the characters from books I read from time to time. What we're doing here is basically we're creating an interval, a flux interval, so it basically emits a tick every second. We zip this with an infinite stream of random characters from the list from the array up there. We just take out the second one, because zip width would create a tuple of 2, because the first argument would be the tick, the second would be the person. And then we go on with, down here, we have a reactive CRUD repository. We're going to save it to the repository. We're going to do a simple, just print the result out once it's saved. Because if we go down a little bit, there is an ID argument, which is by default it's null, and once it's saved, it gets basically filled with the ID assigned to the entity. And then what we shouldn't forget is basically we need to subscribe to trigger the actual execution. So let me quickly run that so far. If everything works out, I hope I can read it up there, is that basically now down here the application already starts storing stuff into MongoDB. I'm using a flapdoodle embedded MongoDB just for the purpose to consistently lose data instead of just eventually losing data. So basically every time I restart the application, all the data is gone. And one thing I wanted to mention, all this stuff here, of course, happens deferred, so it doesn't block in any way, because otherwise, if I was blocking in here, I wouldn't come to this point, because this is an infinite stream, actually. So this winter is coming wouldn't ever be printed, but as you can see, it is, and everything is running in the background, actually. Okay, so let me quickly create a control, a REST controller. Oh, I already prepared it. Nice. And do some get mapping for, let's start it there, return a flux of person, call it flux persons. Let's say we have a parameter named string name in there. And what I want to do is here is this repository find all by name, and I put in the name in here. Oops, I should of course create that method. Perfect, and return that stuff. What did I do wrong, actually? Pardon? Oh, yeah. Thank you. Oh, and this is still void, so this should of course return a flux of person. Good. So this would just go on and use Spring Web Flux behind the scenes. So we're basically going through the going to repository, requesting some data, passing it on to Spring Web Flux, and then this just renders it to the REST endpoint all the way down, pretty reactive. So let's start that, and while the application starts up and starts emitting data, I should be able to go over here and curl that endpoint, 8080, name Eddard. Do we have an Eddard already? No, we don't have, but there is Rob is already there. Rob. Very nice. Oh, yeah, my fault, I'm sorry. I should of course use a proper request parameter, and I should of course pre-print that stuff that then it looks a little bit nicer. So you can see we just used the derived query in there, and then everything works out pretty nicely so far. Let me stop that. And as you know, Spring is about having the choice. Who of you is using RxJava currently? A few of you. You like it? Well, yes. Yeah, you like it. Okay, so if you're used to RxJava already and you don't want to have, let's say, the repository to work with different types, so you want to have your RxJava types because you're used to them, then you could basically just go on and say, let me return an Rx observable over here. And let's see how that works. So basically with Spring Data, we detect, as we did before, the return type you choose, and then just wrap the flux that we're working with internally into the desired return type. So we got stuff for RxJava 1 and RxJava 2 actually, and so you're free to use one of the both and just return it from the repository type, and we'll convert the fluxes just into the type you like. So, and if I didn't mess up again, we should be good to go, and this should still work, and we should still be able to see basically the same output. No, we don't have, but we have John in here already. Jon Snow, there you go. You see, works pretty fine, so you can choose whatever reactive library you actually want, and we'll do the lifting for you to have the return types in there. There's one more thing I wanted to show you, and this is something special for MongoDB. So MongoDB has the notion of capped collections that allow you to create, to use a tailable cursor. So this basically allows you to get notified by the database whenever a new entry is entered into the database. Okay, to do that, we basically have to go on and define the collection as a capped collection. So what I would do is template create collection for the person class, person class and give it collection options, not the empty ones. New collection options, let's say we got 10,000 documents in there, and this is a capped collection. You'll again notice in here, this is not the reactive Mongo template, but this is just the plain old imperative Mongo template, because I want this to happen right now when I'm invoking that stuff, not maybe deferred at a later time, because then eventually I already started inserting data into my database, and it wouldn't make any sense to declare the collection after it already has been created by auto creation of MongoDB, so that wouldn't make any sense. Okay, next thing I need to have is I need to declare my method in there. So this would be find all by. And I need to return a flux of person. So what this does, this is basically a Spring Data MongoDB specific annotation, which tells us, okay, on a capped collection, we want to have a tailable cursor actually, and we want to return an infinite stream that has to be closed at some point. Good. And for the REST controller, we could create something like flux of person, and this would be a stream. Return repository dot find all by, and we map that to, let's say, stream value. And what we have to do is to make this server sent events is basically this produces media type text event stream. So that's basically all we gotta do to have server sent events pushed from the database straight to some REST endpoint. So if I quickly run that one, then we start to emitting data. We're going over here. Let me just move down a bit. Let's call this stream. And there you go. So you can basically, if I scroll down there a little bit, you can see basically data is inserted in the database and immediately emitted directly from the database via that endpoint and the tailed cursor to a potential client. So you'd be wondering what happens now if you basically go on and say, let's say, well, let me make that a little bit bigger. You go there and you curl the same endpoint again. So what would you expect to happen? Let's say 8080 stream. So this would go on, and since we're not sharing the flux, it will go on and create a new connection to the database with a new tailable cursor and returning that. So be careful when doing so, and make sure you share your fluxes properly. And the thing you have to be careful about is that you don't just call share in here, because what share actually does, it sets a threshold on the flux itself, so it won't close as long there is at least one subscriber to it. So that won't work. But you gotta have an instance of the flux and cache it, and then just return it. So be aware of that, and not just think it will work automatically by just putting the share stuff in there. But think about what's happening, because you just get another flux with the threshold that won't close. Okay, so actually the connection is staying open as long until the actual client is closing the connection. And you can see that down here by this nice MongoDB exception. That one will be fixed in the next release of this MongoDB Java driver. It's already a known issue on closing the tailable cursor that this exception will occur. But by having this one in there, you can see that actually it's closed so far. Great. Let me just jump over the slides a bit, because we've seen the demo so far. What I'd ask you to do when you leave this conference is really give the stuff a try. So there is Spring 5 is out in RC1. We have Spring Boot 2 in milestone 1 available, and we got Spring Data in current milestone 3. So please go on, play around with it, and tell us what you think. Is it used? How could you solve problems with it, or what didn't work? Or maybe you have new ideas for us, or you find issues in the code. Please report them back to us. Feedback is always welcome. Might it be positive or negative? We appreciate it if you take the time to just tell us if it's working or not working, or if it's not working, what's not working, so that we can really improve until we go GA with all that stuff. Having that said, I thank you very much for your attention. I hope you enjoyed the rest of the conference, and I hope to see you next year here in Barcelona. Goodbye, thank you.